So now for the next part, we'll be doing about the velocity time graph. What? Velocity time graph. So now let us have a different approach here, okay? So initially what I did, first of all, I mentioned the situation and then I draw the graph, isn't it? So now what I'll do, in order to make it easier for understand, to have a deep understanding what we'll be doing, we'll draw that graph first and see what type of velocity can I bring out from them, or what information can I bring out from them, okay? So let us start the video. So initially say, if the graph, say this is your origin and this is your time. We know in x-axis we usually represent time in unit as second or hour. And in the y-axis let the velocity be there. And say the velocity is in meter per second, or it can be in kilometer per hour. You can see in the previous video, isn't it? The unit of velocity is meter per second or in kilometer per hour. Okay. So now, say initially the graph represented in this way. Okay, say it is a straight line graph. So what do it is? See, in place of displacement time graph, this is the graph for rest, a body at rest, isn't it? In the last part we did that the body at rest in a displacement time graph will be presented in this way. But here what we'll be doing? See, in this graph it is a velocity time graph. So what information can I derive from it? So first of all, we know we have to derive two information in all of the graph, that is the area and the slope. What does it give? Now we know first of all the area. Area we know. In area what we have to do? We have to multiply y and x axis, isn't it? We will be multiplying these two axes, isn't it? So what I'll be doing in the y axis it is the velocity and in the x axis it is the time. So we know velocity into time will give me what? What it will give me? It will give me displacement. Velocity into time is the formula for displacement. That means this whole graph, if I join this part, it will be represented by a rectangle. So this rectangle will give me the displacement of the particular body here. How much he have moved with this velocity, how much he have moved. Now for the slope part. Now see, slope, what does it represent? Now you see, slope means what? I have to divide this y and x axis. So in y axis it is the velocity and in the x axis it is the time. So if I divide this two time, velocity by time, it will give me what? Velocity by time is the formula for acceleration. In the last video I told about acceleration. The formula for acceleration is change in velocity divided by time. Okay, so now, so we know two of the data, that the area of this graph will give me displacement and the slope of this graph will give me acceleration. Now for the next part, what is the acceleration actually here? So let me find the slope here first. So as you can see, the first point, it is from origin. If I draw the perpendicular from this point, the x value will be 0, and say here, say the value is 2. Okay, say the value is 2 here, so 0, 2, and at this point, if I put down the perpendicular, say this is 5 and the y-axis value is 2. So if I use the formula for slope y2 minus x1 by y2 minus y1 by x2 minus x1, so y2 is here how much? 2 minus 2 divided by 5 minus 0. See, y2 is this value, x2 is this value. Okay, similarly here also x1 is this value and y1 is the initial ordinate of this point. Now you see, from this part I will get a value of 0. 2 minus 2 is 0. That means that the slope which gives me the area of the graph is, the area of the board, the slope gives me acceleration, not area. I was confused a bit. So the acceleration of this particular graph is 0. What do we mean by acceleration is 0? That the velocity is uniform, because in the last video itself we studied that if the velocity is uniform, then and then only the acceleration is 0. So the third points tell me that the velocity is uniform and the acceleration is 0 in this case. Okay, and last but not the least, what about the body is at rest or in motion? The body is at motion only. See, the body is moving, isn't it? It is a particular velocity, uniform velocity. So anybody who have a uniform velocity will always be in motion. Let it be uniform motion or non-uniform motion. Okay, so this type of problem can also come in your exam. In that part, they can either mention the case and you have to build up the graph, or they can give you the case, they can give you the graph and you have to mention these points. Okay, so for the second parts or the second case, let me do another graph. See here. अच्छे से समझ लो, होमवर्क मिलेगा, ठीक है? इसके ऊपर होमवर्क मिलेगा. So for the second part, say here it is the time and here it is the velocity in meter per second, and say the graph is a straight line graph. Now what do you mean by this? Okay, what can you find from here? Now you see, if it is a straight line graph from the origin 0, so here the area will be representing, these 2 points will be the same. Area will be representing the displacement, because velocity into time, if I multiply these two, it will always give me displacement. Velocity by time, if I divide these two, it will always give me acceleration. But what about the acceleration part? What about the value of the slope? So here, let me take certain examples, say 1, 2, 3, 4 second, 5 second, okay. And here 1, 2, 3, 4, these are in meter per second velocity. So as it is a straight line graph, so for 1 it will come 1, for 2 it will come 2, for 3 it will come 3. Okay, so this point, it will be x-axis value is 1 and y-axis value is again 1, here also 2, 2, here also 3, 3. So I will not take further points, I'll just take these 3 points only, okay. So for the initial part, that means this part, from 0 to this 1, 1, what will be the slope here? See here, if I find the acceleration here, y2 minus y1, what is the value of y2? So here then, what is the y2? The first one is x-axis, the next one is what? Y-axis coordinate, okay. So this value is 1 minus, and from the initial value 0, 0, isn't it? So here the y's value is 0, 1 minus 0. And from the next part, that is what? x2 minus x1. x2 here it is 1 minus x1, real value is 0. So the answer will come as 1. Acceleration is how much? 1. Now say, again I found out acceleration. Say it is a1, and for the second part I am finding this acceleration. For this part I am finding this acceleration. So here then, I will be applying y3 minus y2 by x3 minus x2. Okay, so here y3, this is the y3 and this is the x3. So y3's value is 2 minus y2's value is 1 divided by, again x3's value is 2 and x1's value is 1. So the answer will always give 1. That means the acceleration is equal here. That means the acceleration is uniform. Okay, acceleration is same. See, equal values are coming, so acceleration is uniform. So the third point gives me that the acceleration is uniform. And for the last point, see, as the body is having a velocity, as the body is having an acceleration, that means it should be in motion. But what type of motion is this? See, as acceleration is there, let it be what type of acceleration, uniform or non-uniform. If acceleration is there, then it is a non-uniform velocity or non-uniform motion graph. Understood? So these data are very important for understanding this graph. Now, for the third case, let me do another graph. This is the most interesting one. Say the graph is in this way. A curve. What does it represent? Say 1, 2, 3 and 4. This is in time in second and velocity in meter per second. 1, 2, 3, say up to this much I am draw. Now say from 1 if I draw the perpendicular, and from y if I draw the perpendicular, say here it is 0.5. It is not near to 1, so let me take it in the middle. It is 0.5. So now the initial point is 0, 0 and this point is how much? 1 from the x and y is 0.5. Similarly, from 2 if I draw, then and it will come in 1, isn't it? So x-axis value is 2 and y-axis value is 1. So I've taken 3 points here. The first one is 0, 0, next one is 1, 0.5 and the last one is 2, 1. Understood? Now the same thing I'll be doing here. I'll derive some information from this graph. Now first of all, what information can I take from this graph? See, it is still a velocity time graph. So if I multiply this 2, velocity into time, it will give me area. That means the area of this graph will give me the what? It will give me the displacement. Okay. Similarly, if I divide this 2, it will give me the slope, and the slope of this graph, velocity by time, will give me the acceleration. Now what type of acceleration is this? This is very important. What type of acceleration it will give? Now you see, from the initial point, from here to here, the value of, see here then the value of y is 0.25 and here the value of y is 0, here the value of x is 1, here it is 0, so it will be 0.5 by 1. If I find the value, it will come 0.5. Okay, here then these two values, between these two values, if I find, see here the value of y is 1 minus y2 is how much? 0.5 divided by 2 minus 1. x2's value is 2 and the x1's value is 1. So here then it will be 0.5 by 1. Okay, this is very interesting. Okay, this is very interesting. Let me take, see here, let me take this value to be a little bit above than 1, then you will be understand. Okay, let me take the third value. See, until now it is uniform. Okay, let me take the third value from here, 3, and it is coming approximately here. Okay, approximately here, so it is, say for example, 2.2. So here the x's value is 3 and the y's value is 2.2. Let me find another acceleration. See, until now the acceleration's value from the initial case also it is 0.5, for the second case also it is 0.5 only. Okay, it is 0.5 only. Now about A3 from the third case. Third case, if I find the y's value is 2.2 minus here the y's value is 1, here the x's value is 3 minus 2. So it will give me 1.2 by 1, the answer is 1.2. Now you see, in this type of curve, what happens? The acceleration initially it was same, but ultimately in the third part it came to be a bit bigger than the initial values. That means the acceleration is not uniform. It is not uniformly equal at all points. That means the acceleration is changing. So from the third point you can understand that the acceleration is non-uniform. And as I know, let it be acceleration is uniform or let it be acceleration is non-uniform, this always means that the velocity is non-uniform or the motion is non-uniform. If acceleration is there, then always the velocity is non-uniform. Let it be acceleration be uniform or non-uniform, this will always remain non-uniform. Okay, now if you understood these parts, I'll be giving a particular problem in the comments below. Try to do that part and give the answer in the comment. Now for the last part we'll be doing two exception graphs, very special exception graphs. Say whenever say it is a velocity time graph, say the time is in second and the velocity is in meter per second. Velocity is in meter per second, you can give it in kilometer per hour also. Now what happen, you see, say if the graph is in this way. So many times they will tell you what do we actually derive from this graph. Okay, so let me give this at 0.4. Okay, 0.4. Now you see what do we actually derive from this graph. First of all, the area. We know area of BT graph will give me what? It will give me displacement. Very good, displacement. Next, there is your slope. If I find the slope, that means I have to divide this to velocity by time. It will give me acceleration. Number 3, these two are same as the previous one. Okay, these two are same. Now what the acceleration part? If you find the acceleration, see, if I take the initial and the final point, I'll not take any middle points. Initial, just the initial and the final point. This is 1, 2, 3, 4, and say this is 5. It is 1, 2, 3, and say this is 4. So initial point, the x value is 0, and the y's value is 4. And the final point, the x's value is 5, and the y's value is 0, isn't it? So if I find the slope, I know I can apply this formula y2 minus y1 by x2 minus x1, isn't it, boys? Boys and girls, is this the formula? Okay. So now if I want to find, कभी-कभी मजाक भी कर लेता हूँ, ठीक है? तो ये वाला अगर निकालना है तो देखो y2 कितना है, यहाँ पे y2 कितना है, ये वाला है पहला वाला पॉइंट, सो ये वाला 1 होगा, ओके, x1 एंड y1. ये वाला दूसरा वाला पॉइंट, सो ये वाला क्या होगा, सेकंड नंबर पॉइंट होगा, ये वाला होगा x2 एंड ये वाला होगा y2. याद रखना है पहले वाला पॉइंट होता है x का होता है और सेकंड वाला होता है क्या, y का पॉइंट, ठीक है. अच्छा, बाद में अगर 11-12 में जाके तब समझोगे ये वाला एब्सिसा और ऑर्डिनेट बोलते हैं इसको, ठीक है. एक्स और वाई कोऑर्डिनेट नहीं बोलते, एब्सिसा और ऑर्डिनेट बोलते हैं, ठीक है. बट अभी के लिए ये समझ लो कि पहला वाला पॉइंट होगा एक्स का और दूसरा वाला होगा वाई का, ठीक है. तो now you see this y2's point is 0 and this y1's point is how much, 4, x2's point is 5 and x1's point is 0. So the value will be minus 4 by 5. That means you are getting a negative result. That means acceleration value is negative. See, slope is giving me acceleration. So this slope's value will be the acceleration value, isn't it? So acceleration here is what? Negative value. Now acceleration's negative value. Now in the last video I have told you that acceleration and velocity, their values can come in negative. What does this mean? In the last video I told you that if the value of acceleration is negative, it means it is having a retardation. That means you are applying the brake. Say you are going with your bicycle and suddenly a car comes and you apply the brake, your velocity will decrease with time, isn't it? Your velocity will decrease. So this means your velocity is decreasing. Acceleration negative means your velocity is decreasing with time. That's why you have begin with a velocity of 4 meters per second, and after 5 seconds, as you apply the brake, after 5 seconds your velocity became how much? The velocity became 0. Velocity is in the y-axis, isn't it? The y-axis value is 0. The velocity became 0. Okay, that means you stopped. Okay, ultimately this value stopped. Okay, so these three parts I can derive from this particular point. Yeah, you can add another one also, that the velocity, as acceleration is there, so velocity will be non-uniform always. And for the last graph, say if the graph is not a straight line below, and say it is starting from here but it is a curve. So what does this mean? Now you see, I can derive this directly now. As we have studied so many graphs now, you and me, we have studied so many graphs here. Okay, so we can derive these values directly. Okay, now before deriving, please do subscribe my channel. It motivates me a lot to make these videos for you. So if I want to find the values directly, see area and slope, it will be the same here. Okay, area will give me displacement, slope will give me acceleration. Now about the slope's value. Now as the graph is decreasing, I can, without calculation, I can easily tell that the value will be negative itself. It may not be minus 4/5, but it will be negative, isn't it? So the velocity will be non-uniform and the acceleration is retardation. Understood how to do it directly. If the value, if the velocity time graph is decreasing from the initial point, if it is decreasing, it is coming below, then always remember it is a retardation graph and the acceleration's value will be negative and the velocity will be non-uniform. Understood? Okay. So study hard and follow this part, and I will be giving the question in the comments. Okay. Do that and show me. Okay, thank you.